Welcome back. So yesterday I put up a video about kind of where the inverse trig functions come from and how and a quick review from Algebra 2 on what an inverse is, what it means to be one-to-one, and when the inverse becomes a function. And we talked about why the graphs of arcsine and arccosine and arctangent, which you see on the screen right now, why they have the shape they do and what the domains and ranges are. I will link to that video at the end of this one. If you're not familiar with arcsine, arccosine, and arctangent yet, I'd recommend going back and give that a look first, because I'm going to kind of use that knowledge as we go through here, because we want to know how we can evaluate these things. And, if you have an actual problem, what that's going to look like. So here's a couple of quick examples, and we'll do some more in just a minute. So something like the sine inverse of 1/2. Or the cosine inverse of negative root 2 over 2. What are they asking? What does the answer even going to look like? Well, if we know what an inverse means, back when you first started doing the unit circle, if I had asked you what is the sine of pi over 6, you would tell me 1/2. So that means if I'm taking the inverse sine of 1/2, it must mean it's equal to pi over 6. Right? So it is true that for this statement to be true, it must be true that sine of pi over 6 is equal to 1/2. Okay? But here's the trick, right? So we do have to keep in mind what the range of the inverse trig function we're using. And again, I talked about that on a previous video. So but I'm going to write them down here for you. So the range of inverse sine is from negative pi over 2 to pi over 2. And we know that's in quadrants 1 and 4. For cosine inverse, it was from 0 to pi, because of how we restricted the domain of the cosine function. And that's, of course, quadrant 1 and quadrant 2. And then the range of tangent was just like sine. It was also from negative pi over 2 to pi over 2, and also back in 1 and 4. Okay? So that's going to be super important as we go through some more of these problems. The nice thing is, if a value is positive, like this first one I did right here, if the inverse sine of 1/2, I know it's in the first quadrant, so it's just going to be pi over 6. But sometimes it gets a little bit tricky. So let's take a look at the second one real quick. So cosine inverse of negative root 2 over 2. So we look at this and we say, okay, the range of inverse cosine is between 0 and pi. So that means my answer is going to be, the way to think about it is, at what angle measure in radians is the cosine equal to negative root 2 over 2, right? Where does that happen? And if you know your unit circle, and we know we're in either quadrant 1 or 2, so since it's negative, it's got to be in quadrant 2, so that means it's at 3 pi over 4. And sure enough, that fits inside of our range, because 3 pi over 4 is between 0 and pi. Okay, so that's really kind of what the way inverse functions work, and how to think about evaluating them. But it's really important that you remember the range and remember what quadrants that we talk about going through. And also remember, anytime, even when you start doing applications in a little while, whenever you do an inverse trig function, the answer is going to return the angle measure where that happens. Okay. Generally in radians, but sometimes we need to talk about degrees, but we'll talk about that later. So I just did those first two here, so I'm just going to rewrite the answers just for completion's sake. So we knew that was at pi over 6 in the first quadrant. Cosine of negative root 2 over 2 was 3 pi over 4 in the second quadrant. But let's take a look at this next one here. How about the sine inverse of negative root 2 over 2? Well, go back to what we just talked about. What is the range of inverse sine? And what quadrants is it in? We know it's between negative pi over 2 and pi over 2, so that means it's got to be in quadrant 1 and 4. So in this case here, since it is a negative value, we know we're talking about quadrant 4, right? So think to yourself for a second, where does sine equal negative root 2 over 2 in quadrant 4? The easy answer to that would be 7 pi over 4 because you're used to using circle, right? But we cannot think of it in that way. We have to think of it in terms of what our range is from negative pi over 2 to pi over 2. So if you think about it in that way, and I'm going to do a quick little sketch from negative pi over 2 all the way up to pi over 2, all of a sudden, this same angle that would normally be 7 pi over 4, we have to think about it in terms of going from in the negative direction. So what is that going to be? It's going to be negative pi over 4, and that will be the answer to this question. So negative pi over 4. Okay? How about the arc cosine of 0, the one right below here? Think to yourself, what is the arc cosine of 0? Think about the range of arc cosine. And then within that range, where does cosine equal 0? And hopefully you came up with pi over 2. And again, we're always going to be talking about radians here. There's some application problems you may do eventually that'll have degrees as an answer, but for the time being, we are stuck in radians. How about the inverse tangent of negative 1? We know tangent is equal to sine over cosine, and we also know that the range of tangent is from negative pi over 2 to positive pi over 2. So where does tangent equal to negative 1? We know it's again got to be in quadrant 4. And it turns out to be the same answer we just had over here on the left. So when is the sine and cosine the same numerical value, just different signs? It will be in that fourth quadrant at negative pi over 4. How about the last one down here? This is a fun one. What would the arcsine of 2 be? If you're kind of wondering if something looks weird there, it should, because you should also remember that the domain of the arcsine, or arc cosine for that matter, is just between negative 1 and 1, because our parent functions, if you go all the way back to sine and cosine, those have to always be, and your unit circle values are always between negative 1 and 1. So the arcsine of 2, this is outside of the domain. So there is no answer here. This is undefined. Does not exist. You can't do it. Okay? Now, the last little bit, and I'm going to run through these a little bit quicker, but so this is sometimes you see a question like this also. So you see some kind of some complex ones, and these kind of make logical sense if you just think about it for a minute. So the sine of the sine inverse. Well, what happens to inverse functions? I don't like using the word cancel each other out because it's not mathematically kind of rigorous, but that's kind of what happens. So the sine of inverse sine of 1/2, sure, it's going to be 1/2. Because if you look at it this way, do it in pieces, the inverse sine of 1/2, we know it's in quadrant 1 or 4, since it's positive, it's in quadrant 1. So that means it's at pi over 6. And sure enough, the sine of pi over 6 is 1/2. So there you have it. Same deal. Cosine of the cosine inverse of root 3 over 2, root 3 over 2. By the same kind of way. The inverse cosine of root 3 over 2 is, again, pi over 6. The cosine of pi over 6 is root 3 over 2. But it can be a little bit trickier sometimes, right? So take a look at this one. So the sine of 3 pi over 4. Think to yourself for a second, what's the sine of 3 pi over 4? Root 2 over 2, right? Okay, so now we're saying, what is the inverse sine of root 2 over 2? And again, think of the range of the inverse sine. The range of the inverse sine is only in quadrant 1 or 4. We can't be in quadrant 3 anymore. But this, we have a root 2 over 2 in quadrant 1, so the answer to this is going to be just positive pi over 4. That is where that happens. Okay, so again, we work from the inside out, so the sine of 3 pi over 4, root 2 over 2, positive, and then we evaluate the the inverse sine, just like we had been on the previous slide. How about this one? Arc cosine of the cosine of 5 pi over 6. So again, work inside. What's the cosine of 5 pi over 6? Think of that in your head for a second. We know this is equal to negative root 3 over 2. So now we want to do the arc cosine of negative root 3 over 2. Arc cosine, what's the range? Think to yourself. Or look back through your notes. We know our range here is from 0 to pi, so the first two quadrants. So sure enough, the arc cosine of negative root 3 over 2, that's got to be in quadrant 2, so we know that's 5 pi over 6. So this one works out just kind of the way it would be anticipated to. How about the one down here? Cosine of the arc cosine of 3. It seems like we just cancel those out again, but 3, but yo, look at it. We did one of these a second ago. Can I evaluate the cosine inverse of 3 not in domain? That does not exist. So there's no answer for this one. Can't do it outside of domain. And then the last one, we're not going to be able to do this one by hand because this comes out to kind of a weird decimal answer, but we can set it up. Remember, and tangents are easy. They really are, because remember the domain of the arctangent can be literally anything. Okay, so it doesn't matter what it is. So we're talking about the arctangent of 3, the tangent of that. They will just, again, for lack of a better term, cancel each other out. So the answer there is going to be 3. Okay, so we're going to do some more of these in class, but I hope that gives you a quick little overview of what happens when you are evaluating an inverse trig function. Remember that it's always going to return an angle, but you have to keep in mind what your range is on each of the 3 functions. I'll post a link to the intro part of this when I talk about inverses and things like that. That should be on the screen right now. And please feel free to subscribe if you want to see some more videos about pre-calculus and trigonometry moving forward. Thank you again for watching. Have a great day.